Two isolated point masses P of mass m and Q of mass 2m are separated by a distance d. X is a point at distance d from P and 2d from Q. What is the net gravitational field strength at X and the net gravitational potential at X? And you can see options, and it's of mass m and it's of mass 2m. So what about gravitational field? You know that force, it's a vector, is equal to mass times gravitational field strength. It's a vector, and since mass is a positive value and the gravitational force is always attraction, so Q is attracted to mass P and is attracted to mass Q, hence field strength is always directed to the mass which produces a field at some point. So if we consider that mass Q produces a field at X, so a vector of field strength will be directed to P, and it will have a magnitude of what it is. It's actually force, but there is only a mass which produces a field, and formula is given in data book and divided by distance squared. So it becomes, don't get confused, it's in general mass of object which will be placed at X. It's not this. So magnitude becomes what? Constant, universal constant. Mass which produces field at X, it's just m divided by distance, just d squared. And field produced by Q at X also directed to Q and will have magnitude what? G 2m divided by 2d squared, and it becomes 2gm and 4d squared, or gm over 2d squared. And since gravitational field, it's a vector, the resultant vector, it's the difference because two vectors are in different directions. You can see that it's like 1 and it's like a half. So the resultant field will be to the left, and magnitude will be a half gm divided by 2d squared. It's like force of 10 newtons to the left and 5 newtons to the right. So the resultant force is 5 newtons to the left. And what about gravitational potential? Potential is a scalar, not vector quantity. It has magnitude only, and the resultant potential is just the sum of individual potentials. And we need formula for potential and gravitational potential. It's minus gm over distance. And potential produced by P at X, it becomes just negative g m over d, and potential produced by Q at X, it's what? It's negative g 2m over 2d. And since potential is a scalar quantity, the resultant potential is just the sum of individual potentials, and you can see 2 cancels and it becomes negative 2gm over d, not 0, and hence you can see that d is correct. And that's all for this question.